All right, let's talk about a question that seems almost simple, but when you really start to pull at that thread, it unravels one of the biggest, most important mysteries in all of physics. It's really the secret to why anything exists at all. Let's get into it.
No, I'm serious. Look at your hand, or the desk you're at, the phone you're holding. It's all made of atoms, right? And for a really long time, our best understanding of how the universe worked predicted that every single one of those atoms should have collapsed on itself in less time than it takes to blink. So, why are we still here?
To get the answer, first we have to really understand the problem. And the problem comes from the old rules of physics, the classical, intuitive rules that make sense for things like baseballs and planets, but that just completely fall apart when you get down to the super, super small.
We all learn this picture in school, don't we? The Bohr model. It's so clean and easy to imagine. You've got the heavy nucleus sitting in the middle like the sun, and then these little electrons are just zipping around it in nice, neat orbits like planets. It feels right, it makes sense, or at least it seems to.
Here's the kicker. In 19th century physics, there was this rule that was basically set in stone. If you have a charged particle and it's accelerating, it has to give off energy as radiation. And guess what? An electron zipping around in a circle is constantly changing direction. That, by definition, means it's accelerating. So it has to be losing energy all the time.
So just follow the logic here for a second. The electron's orbiting, so it's accelerating. Because it's accelerating, it's constantly losing energy. And an object in orbit that's losing energy can't stay in that orbit. It slows down, its path decays, and it starts this terrible, inevitable spiral inward, pulled closer and closer to that nucleus.
So how long would this atomic death spiral actually take? Well, according to the math of classical physics, it should take about 1/100 billionth of a second. That means every atom in the entire universe should have collapsed the instant it formed. But, obviously, they don't. So what does that tell you? It tells you the old rules have to be wrong. This spectacular failure wasn't an end, though. It was the beginning. It forced us to realize we needed a completely new way to understand the universe. A set of rules that are bizarre, totally counterintuitive, but that, actually work. Welcome to the crazy world of quantum mechanics. And this is the absolute key to the whole thing. The rules that work for a planet just do not work for an electron. Down at that subatomic level, reality just plays by a different, weirder set of rules. And the difference is it's night and day. In our world, the classical world, things are predictable. I can tell you the exact path a ball will take. But in the quantum world, it's all about probabilities. An electron doesn't really have a path. It just exists in this fuzzy cloud of possibilities. It's a complete change in how we have to think about what reality even is. So, what are these new rules? How does this strange new physics actually save the atom from collapsing? Let's get into the quantum solution. Okay, the first and probably the most important new rule is something called quantization. It's a huge idea, but it's actually pretty simple. It just means that in the quantum world, things don't come in a smooth, continuous flow. They come in specific, chunky steps. For an electron in an atom, energy isn't continuous, it's quantized. Honestly, this is the best analogy for it. Forget about that smooth ramp from classical physics, where a ball can roll down and be at any height along the way. In the quantum world, energy levels are like a staircase. You can be on this step, or you can be on that step, but you can never, ever be floating in between the steps. Now think back to our death spiral. That electron was supposed to be losing energy continuously, just sliding down that ramp into the nucleus. But quantum mechanics says, nope, can't do that. The electron is on a staircase. To lose energy, it has to make a big, distinct jump down to a lower step. It can't just gradually slide down. And this is the ultimate savior of the atom. There's a bottom step, a lowest possible energy level, and it's called the ground state. Once an electron gets down to that bottom step, it's just stuck. It literally cannot lose any more energy because there's no lower step for it to jump to. It has nowhere else to go. The spiral is stopped before it even gets a chance to begin. So let's just pull this all together, shall we? The atom is stable because 1. Electrons aren't little planets. They're more like weird probability waves. 2. Their energy is quantized. It's the staircase, not the ramp. And 3, there's a final lowest step on that staircase. They just can't fall any further. The rules of the quantum game make collapse impossible.
Now, I know this might all seem like some really abstract microscopic drama, but the stability of that one single atom multiplied by the trillions and trillions of them that make up you and me and everything else, well, it turns out to be the most important thing for our existence. This quantum weirdness isn't just a fun fact for a physics class. It is the literal foundation of why the universe isn't just some boring, uniform soup of collapsed matter. It's the reason we have stuff.
That's right. The fact that you can put your coffee cup down on a solid table, the fact that the molecules in the air you're breathing don't just fall apart, the very fact that the complex DNA molecules that make you can hold their shape, it all comes back to that one simple rule. An electron can't take a step that isn't there. I think this quote just says it all perfectly. You're not just living in a quantum universe. You are a quantum mechanical creature. The same bizarre rules that stop a tiny electron from spiraling into a nucleus are the very same rules that are holding you together right this second.
So, the next time you touch a solid object, just remember what you're really feeling. The strange, probabilistic rules of the quantum world pushing back. Our entire solid, stable reality is built on a foundation of pure quantum weirdness. It really makes you wonder, doesn't it? Thanks for digging into this with me.